Today we're going to be talking about writing an equation from 2 points. So in general, our steps are this. So we're going to find the slope. We're going to choose one of the points and plug in the m, the x1, and the y1 into point slope form. We're going to distribute the slope, and then we're going to move y1 to the other side to get the equation in slope-intercept form. The only way that this is different from the previous lesson is that before they gave us 1 point and they gave us the slope already. Our job today is to actually find the slope between those points first before we proceed in the process of going through. Okay, so we're going to look at some examples, and here is our first one. So we have -2, 4, and 3, 9, and our job is to ultimately write our answer in point slope form at the very, very end of this. Okay, sorry, in slope-intercept form at the very, very end of this. All right, so the first step is to find the slope. So you have a couple of different ways that you can do this. You could technically type these 2 points in Desmos, count the rise over run for them, and simplify your fraction. You could also use the slope formula, which is something that we've been practicing with. So for the slope, it doesn't matter which point is which, but you just need to make sure that you're taking y minus y over x minus x. So I'm going to go 9 minus 4 over, since I started with the 9 in the numerator, I have to start with a 3 in the denominator, minus a -2. Okay, so 9 minus 4 is 5. 3 minus a negative, that's going to become this big plus sign. 3 plus 2 is 5. And I have to simplify this. So 5 divided by 5 is 1. So our slope is 1, and we have 2 points. Well, we just have to pick one of them. So does it matter? I guess we're going to find out. So on this one, I'll show you what happens if you choose either point. All right, so we'll actually draw a line down the center here. We'll do this both ways. You do not have to do both ways in the future when you're doing these questions. So I'm choosing this point. Here's my slope. So we have y, since this is a positive 4, we're going to say -4, equals our slope is 1, times x, that's a -2, so we're going to flip the sign of it to be +2 when we plug it into this formula. This is point slope form because we used a point and a slope. All right, so that's part of our answer. The other part of our answer is to get this into slope-intercept form. So we're going to keep the y minus 4. We're going to distribute that 1 through. 1 times x is x. 1 times 2 is 2. That is not slope-intercept form because y is not by itself, so we're going to add 4 to both sides. The 4 is like terms with that 2. So now we have y equals x plus 6. So just like we did in the previous lesson, you can double check this a couple of different ways. You can type this into Desmos and make sure that both of these points are on that line. You could also take these points, these coordinates, and plug them in for y and x and actually make sure that it makes sense and works. So if I plug in -2 here, -2 plus 6 is 4. And if I plug in 3 here, 3 plus 6 is 9. So they both work, even though I only used that. So y equals x plus 6. So what happens if we would have chosen 3, 9, the point 3, 9 instead? Does it make a difference? All right, so let's double check that and see. So our slope is still 1. This time I'm going to choose 3, 9. Okay, so we're going to have y minus 9 equals our slope 1 times x minus 3, since we have to change the sign of those to be opposite. So that's part of our answer. Now, if you notice, that is not the same thing there. That's okay. You can still get full credit for either of these because they are still both point slope forms, just using a different point but the same slope. Okay, our next step is to distribute. So we're going to take that 1 and distribute. 1 times x is x. 1 times -3 is -3. To get y by itself, we're going to do the opposite operation, the inverse operation. So we're going to add 9 to both sides. And that's going to give us y equals -3 plus 9 is a positive 6. So did we get the same answer here? Absolutely, we did. And so that just goes to show you it does not matter what point you pick. You have to get the correct slope. The slope is 1, all right? And then you're choosing a point and you're plugging it in just the same way that we did before, okay? So let's take a look at another example here. All right, here we have the points 7, 5 and negative 2, 5. And again, we're going to write our final answer in slope-intercept form. So the first thing we have to do is find the slope, okay? So again, it's going to be y minus y over x minus x. So I'm going to take 5 minus 5 over negative 2 minus 7. So 5 minus 5 is 0. Negative 2 minus 7 is a negative 9. And simplifying that, we get a slope of 0. Okay, because 0 divided by anything is 0. So we're going to pick a point. Typically, people choose the first point often. It does not matter, though. We just showed that, and you only have to pick one. So we have y minus 5 equals our slope is 0 times x minus 7. Okay, so technically that can be your point slope form. That's fine. All right, you can show me that you have your point, you have your slope, you're good to go. All right, so then we have to distribute. Now, when we take that 0 and we distribute it in, 0 times x is 0, and 0 times negative 7 is 0. Well, 0 minus 0 is still 0. So when your slope is 0, this whole side becomes 0. To get y by itself, we're going to add 5 to both sides, and y is going to equal 5. So remember, if it has a slope of 0, that means that it's a horizontal line like this. And so we should just be getting y equals some sort of number, okay? And if you look at these, both of these have a y value of 5. So that tells us that our equation is correct because they both have a y value of 5. All right, let's take a look at another one. So we have the points 1, 2, and 1, 7. And we're going to do the same steps again. So we're going to find the slope between them. So 7 minus 2 is divided by 1 minus 1. 7 minus 2 is 5. 1 minus 1 is 0. 5 divided by 0 is undefined. Okay, so now you're asking yourself, how the heck are we going to do this if our slope is undefined? So what does it look like? If our slope is undefined, that means that our line goes straight up and down. And if it goes straight up and down, it would only cross the x-axis. So this is going to be an x equals equation. This is the rare case scenario. It doesn't happen very often, but this is the rare case scenario where you're just going to have x equals, not a y equals for your answer. Well, if we're looking at both of these points, they both have x equals 1. And so x equals 1 is going to be our answer for this question. Again, that only happens if your slope is undefined. Let's take a look at one more here. So we have the points 5, 8, and 7, 5. So first step is to find the slope. So 5 minus 8. Since I started with this 5, this y value of 5, I need to start with the x value of 7 and then subtract my 5. So 5 minus 8 is negative 3. 7 minus 5 is 2. So our slope is negative 3/2 because that cannot simplify. Okay, so we're going to pick a point. I'll go ahead and pick the first one here. All right, so we have y minus 8 equals our slope times x minus the x coordinate, which is 5. That's the first part of our answer in point slope form. The next part is to get it into slope intercept form. So the y minus 8 stays. Negative 3 times x, sorry, negative 3/2 times x is negative 3/2 x. Negative 3/2 times negative 5. So negative 3/2 times negative 5. Remember, when we multiply fractions, we just multiply straight across. So negative 3 times negative 5 is a positive 15, and 2 times 1 is 2. To get y by itself, we're going to add 8 to both sides. So y equals negative 3 halves x. And then to add these, we need to get a common denominator of 2. So 15 halves stays there. 8 in halves would be 16 because 16 divided by 2 is 8. And when we add those two numbers together, we get 31 halves. Okay, so this is our answer in slope-intercept form. Now, with this one, halves would just be 5/10 or 0.5. So you could use decimals if you wanted here, but on our first one, or like if this wasn't a nice easy decimal, not on this, sorry, it wasn't on any of our examples here, but if this here was negative 2/3, and that's not a nice easy decimal, I would not suggest doing that. I'm going to suggest that you keep them as fractions, okay? And that's it.